Ever wondered how massive platforms like Netflix, Amazon, or Google handle millions of requests per second without crashing? The secret lies in load balancers, the backbone of high availability and scalability in distributed systems. But did you know that not all load balancers work the same way? Today we are diving deep into layer 4 load balancers, also known as transport layer load balancers. These are responsible for routing traffic based on network level information like IP addresses and ports. Okay, what is a layer 4 load balancer? Let's understand where the layer 4 load balancers operate first. The OSI model consists of 7 layers, and layer 4, also known as the transport layer, is responsible for end-to-end communication. It handles TCP and UDP connections, ensuring data is delivered efficiently. A layer 4 load balancer sits between the clients and the backend servers and directs incoming traffic based on destinations, IP addresses, and port number. It doesn't inspect the actual contents on the requests, making it a fast and efficient for like handling high throughput traffic. Okay, let's try to understand how it works. First, a client sends requests to a public IP, like when you access a website or an application like youtube.com or something. And the layer 4 load balancers checks the incoming request's IP address and port and picks a backend servers to handle it. Step 3, the request is then forwarded to the selected backend servers without modifying the application layer data. This makes layer 4 load balancing extremely fast and lightweight. The backend server processes the request and sends the response back to the client through the load balancer. Like imagine an online game server handling thousands of players, a player for a layer 4 load balancer ensure traffic is evenly distributed across multiple servers, preventing overload and reducing latency. Okay, so there are as also algorithms in load balancing. I guess there is the round robin, least connection, IP hashing, and weighted load balancing, and we did talk about them on pretty high level in the previous videos, so I'll not talk about them in this video. We'll create videos to discuss each algorithm in like by itself, and we'll discuss its pros and cons and when to use it. Right now, I guess we need to talk about the benefits or why um, the layer 4 load balancers is quite useful. Benefits. The first thing, we have high performance. Like since they work at the transport layer, they don't need to inspect HTTP headers, making them much faster. Number two, efficient traffic distribution. Like it helps avoid overloading any single server, ensuring reliability. Number three, scalability. It's easily scales to handle millions of connections per second. For security and DDoS protection, like by spreading traffic across multiple servers, they help mitigate large-scale attacks. We could talk about the layer 4 load balancers versus the 7 layer load balancers. The layer 4 load balancers, first, it works at transport layers, routes traffic based on IP address and port. It's faster and more efficient. And the 7 layer load balancer, it works at the application layer, routes traffic based on URLs, HTTP headers, cookies, allows content-based routing, different servers for image and videos, for example. Which one should you use? It depends on your needs. If you need a high speed, routing and efficient resource distribution, layer 4 is the great choice. Otherwise, you use layer 7. Okay. Um, I guess that's it for this video. So like we can wrap it up or go to our conclusion. Layer 4 load balancers are the foundation of modern high-performance distributed systems, whether you are running a web application, a cloud-based service, or a multiplayer game. They help keep traffic smooth and efficient. So that's it for this video, and see you in the future.